And then this is in my order, so it's 1, 2. Okay. Well, and then you want to write the result there.
So you'll see that you'll have a problem while calculating here. It's not going to be simple at all. Actually, yeah. Go ahead.
I think it's simple.
Is it not straightforward?
No, it's not straightforward. It's not straightforward.
No, I think
Do IXSX commute with IZ?
No, the window, like here at the bottom. So you're just going to have 4 terms.
Well, actually, it's double quantum and zero quantum evolution. If I'm not mistaken.
At the very bottom, you can just rearrange the terms in such a way that you're just going to have 2 things independently evolving.
I don't agree with that.
What's to disagree with? Right.
Hold on a second.
These 2 commute with one another, and this one commutes with this one, so you can move it over, and it commutes with this.
Yeah, but we're not talking about IX here. We're talking about IXSX.
IXSY.
Yeah, IXSY. I mean, hold on a second. Let's wait for what Scott is doing here.
That's my guess.
I think that's correct.
I don't think. Oh, wait a minute. I'm not sure here.
I'm almost entirely certain that's correct. That's the logical.
I mean,
this thing
from the book, so we can just look it up. They were all really simple.
Do you have solutions to the exercise, or?
Yeah. I mean, they were just like examples that are in the book. So.
Let me show you what it is. Right. So if we have e to the I omega 1 IZ plus omega 2
that would be able to.
IX SY e to the I omega 1 IZ plus omega 2 SZ, right? That because these 2 commute with one another, that's e to the I omega 1 IZ e to the minus I omega 2 SZ IX SY e to the I omega 1 IZ e to the I omega 2 SZ, right? And then these 2 commute with one another, and these 2 commute with one another. So now we have e to the minus.
What do you mean by these 2 commute with?
Omega e to the minus I omega 2 SC and IX commute.
Yeah, but we're not talking about IX. We're talking about IXSX. It's not. You cannot separate it from the.
No. Look, you can, right? Because these 2 terms commute.
Oh yeah, right. Okay.
So the next step is that you have e to the right IX e to the I. If it were up here, that would be a different story, right? Omega 2 SZ SY e to the I omega 1 SZ e to the I omega 2 SZ, and then we can do the same flipping with.
Yeah, right. It makes sense. That's all right.
So in the end,
and actually, I know what was disturbing me now. Okay. So it's funny. Yeah, I will make a comment on the result that Scott wrote, which is right.
e to the I omega 2 SZ SY e to the I omega 2 SZ. So they're going to just evolve independently. You'll have 4 terms. You'll have sine and cosine for this one, sine and cosine for this one, and you get Scott's result.
Right. Okay. And so what I was wondering about Scott's results is that I am absolutely certain that IXSY is something that has zero quantum and double quantum coherences. I actually didn't know that there was also. I didn't realize that there was also a single quantum coherence in that stuff. But here is the thing: zero quantum coherence evolve at delta omega, so that the frequency difference between I and S, and the double quantum evolve at the sum of the frequencies of I and S. So here, what we're looking at, if we're looking at the IXSY term, you have cos omega 1t minus cos omega 2t, and you can collect this term into a cos omega 1 plus omega 2t.
Yeah,
And
how does this actually give that? Doesn't this give something like minus IY, well, with I's and whatever.
Right, it'll be IY cosine plus, or IY sine times cosine.
Yeah, so it's not going to be.
I don't know. I'm sure you can rearrange it so that it comes into something like that. I'm assuming that they work out to be the same because I'm sure that one's the case, and I know that one will have 4 terms, and there'll be those cross terms, and they'll be multiplied.
But he's right. The terms that'll go like sine omega 1.
yeah, I'm just surprised. So the reason why I'm surprised that there is this sine omega 1 thing and sine omega 2 thing is that when you write the matrix. So if I'm not mistaken, let's actually write the matrix because I can tell for sure what it goes at what frequency when I see the matrix. So let's do it this way. So we have Ix, which is 0, 1, 1, 0, and Sy is this what we're looking at, which is minus I, 0, 0.